our next presenter. Maria Diaz and Michael Winkler. I'm going to read their bios real quick here, but hi, Maria. Hi, Michael. These are our, Michael's my partner. Maria is one of our early staff and our longest time staff. So Maria Diaz is a building energy analyst at Redwood Energy who graduated from the Environmental Resources Engineering program at Humboldt State University, now Cal Poly Humboldt. Maria mainly works on building energy models for affordable housing, low-rise and high-rise multifamily buildings and single-family homes in California. She previously worked for Integral Group, doing building performance models and Title 24 and LEED. And in addition, she's also part of our research team here at Redwood Energy. Michael Winkler designed and lives in a remodeled net zero house, was part of the engineering teams that designed one of the nation's first cell phone systems and the world's most efficient hydrogen fuel cell, and has programmed a version of the California Utility Allowance calculator that is more accurate with zero net energy developments. Michael's uniquely skilled at this. In addition to multiple energy credentials, Michael is also a software engineer, and Michael served for 8 years on the City Council of Arcata, and he was also our mayor. So Michael and Maria, welcome.
Hello, everyone.
Hello.
Go share my screen. Let me know when you can see my screen.
It's perfect.
My video is not active yet.
It's okay. I mean, you guys are both beautiful people, but it's your minds that we appreciate.
Oh, let's go back. Okay. Hi, everyone. Again, my name is Maria Diaz, and I am presenting with Michael Winkler. We're both from Redwood Energy. And today our presentation will be on the CUAC tool. So our outline for our presentation is, we're going to start with what is a CUAC, give a brief history, the benefits of the CUAC, how does the CUAC work, the CUAC and CEPE 2022, comparison of the current and the new CUAC, and desirable future capabilities, and we'll have some time for questions. So what is a CUAC? CUAC stands for California Utility Allowance Calculator. It's a tool designed to calculate project-specific utility allowance for low-income housing projects. It is also intended for new construction affordable housing, and it allows for developers to receive a financial incentive while being able to make buildings more energy efficient and add PV more than the minimum requirements. In addition, the developer that are using the CUAC for the projects, they must include energy efficient upgrades and or have on-site PV in order to qualify. One thing I do want to emphasize is that Redwood Energy is the leading CUAC company in California. Redwood Energy has done the majority of the CUAC projects in California over the past 12 years. So a brief history. The development of the CUAC started in 2007 by the Affordable Housing Advisory Committee from the NSHP, the CC, and CHEMA. The CTCAC approved the CUAC as California's energy consumption model software in January 2009. So what are some of the benefits of the CUAC? So the developer who uses a CUAC will be provided with a financial incentive, which depends on their building unit type, the energy efficiency measures that they use, and utility rates. There is a lower environmental impact since the buildings are more energy efficient and also include PV. And in addition, the tenants get a higher quality housing and stabilizes their utility costs. So now Michael will go ahead and talk about how it works in more details.
All right. One thing I wanted to also emphasize is that the utility allowances set the cap on the rent that the developers can charge the tenants. And so traditionally that was done using a standard rate sheet from the local housing authority. And what the CUAC tool does is allows that to be based on the actual energy performance, use of PV, and energy efficiency. So the process starts with a consultant, a certified energy analyst, who's qualified to develop this energy model. And so the energy analyst builds the energy model with one of these computer-based tools approved by the state of California. let's see, that would be either Energy Pro, which is the commercial version, or CEPE, which is a free tool from the state of California. And the model is based on splitting the energy models by the number of bedrooms, because each number of bedrooms has a separate utility allowance, that the smaller apartments use less energy and the larger apartments use more energy. And what happens is that the analyst takes the model, splits it up into a number of bedrooms, runs the model on the computer, and then does post-processing with a software provided by the state of California, running under Microsoft Access, and produces a utility cost, as I said, one for each of the bedroom types, as we call them. And once that is produced and signed by the analyst, it goes to the developer, who signs it and submits it to the California Tax Credit Allocation Committee. Okay, next slide, please. Right. Choices, as I said, are either Energy Pro, the commercial software that we primarily use for this process, CEPE, the state free software, and then the developer takes those energy models and then runs the simulation. Next slide, please. All right, this is the user interface for the current CUAC tool running under Microsoft Access, where the analyst takes the output of the modeling software and enters it into the CUAC tool. Enters the location of the project, number of bedrooms in the project, the name and contact information for the developer. Next slide, please. As I said, number of apartments. In this case, 1, 2, or 3 bedrooms. Next slide, please. And then enters the categories of energy use, which the ones that are regulated by Title 24 are space heating energy use, air conditioning energy use, and domestic hot water energy use. Next slide, please. And then finally, the analyst enters the amount of PV production per month into the tool, so that there is credit for use of PV. On the typical project that Redwood Energy works on, that the amount of PV production in the year is at least as much as the energy consumption. So the majority of projects that we do are zero net energy projects. And we were one of the first companies in the United States to do that, and certainly the first to do that in California. And as Maria mentioned, that we actually do the majority of all the projects under the CUAC tool in the whole state of California. Next slide, please. And then this is an output showing the energy use for each category of use within the building, broken down by the number of bedrooms. Next slide, please. And also the appliances that are used in the apartment or the home, and whether they're Energy Star. And so this includes washer and dryer, and as I said, whether they are Energy Star certified appliances. Next slide, please. And this is the output generated by this tool. And so this would be confirmed by the analyst to make sure that this is what they want. And if you look in the upper right, it shows the annual projected utility cost broken down by the number of bedrooms. In this case, the estimated monthly energy use is $10 for the 2-bedroom, about $11 for the 3-bedroom, and let's see if I'm reading that correctly, $18 for the 4-bedroom. And so rents are capped at 30% of the gross income of the household minus the utilities, so that by lowering the utilities to minimum monthly charge, that we're able to make it so that going forward, even if utility rates go up, that all this will be based on this very low energy use of the apartment. Next slide, please.
Okay, thank you, Michael. So now that Michael went into detail how the CUAC works, I'm going to go ahead and talk about the CUAC in CEPE. For the rest of this presentation, I'm going to refer to the CUAC in CEPE as the new CUAC. So as I mentioned before, for those that don't know, CEPE is a software used to do Title 24 modeling that's approved by the CEC. So what you would do is go to the CEPE website, and then there's a tab for CUAC, and then download the most current version of the CEPE CUAC. In this case is 2022.2.1. So the new CUAC. I'm not going to go into the details of building the model, but just more of like how to use the CUAC and running it. So once you have your complete model running, you want to go to the building tab at the very top level where it's highlighted project, click, and then select the tab where it says CUAC. Enable the CUAC reporting. Right here it shows that error, no residential zones with affordable housing selected. So what we're going to do next is select all the rooms, in this case, all the zones, all the units that are going to be, that you want to run the CUAC for. So you can select either all the zones, all the 1 bedrooms, 2, 3, whatever you have, or you can do individual 1 bedrooms. In this case, you can do the entire building. If it has 1 bedroom, 2 bedroom, 3 bedrooms, it'll run it and it'll not, run it and not have any errors. So then you select all your zones click on the zone, you select the affordable housing unit CUAC, and then press OK. You have all your zones selected. And then you go back to the building tab, the CUAC tab, and you enter all the utility information, the electric utility information, if there's gas, water, trash bill. And then on the right, you have the site location projects. You put all the information in there. At the very right, you see that there is 6 1 bedrooms, 6 2 bedrooms, 6 3 bedrooms, and a total of 18 units. And that's correct because I want to run my entire model. And at the top, there's where it says reports, you can select either draft, final, and annual. In this case, we have an annual report. And then where it says calculate CUAC, calculate and report, and that's how you run your simulation. But before you do that, you want to make sure that you add your PV size in. Even though if it's already included in your model, you still need to add it under this CUAC tab. So what you want to do is click on the PV allocation, and then on the right, it'll pop out the dwelling unit PV allocation. You add your PV size. So in this case, we have 100 kilowatt. And then you want to drop down on the PV billing option. And make sure you want to do that and select PV offset monthly use with carryover. Then you want to add the percent of tenant PV serving each unit, and you press OK, and then you run it. So then once it's done running, you have the option of viewing your view submit a report, view details, or the CSV files. If you want to view the other, this is not going to be popped out anymore, but you can also go where you saved your project file, and then it will have all the reports saved in the same location plus the CSV file. And I will not show a report because Michael showed one previously, but I will go ahead and talk about the comparison of current and new CUAC. So what are the added capabilities of the new CUAC? Uses compliance model without modification to generate CUAC reports for all unit types. As I mentioned, and how Michael mentioned, that in the current CUAC, you have to build separate models for each unit type, and the current and then the new CUAC, you can run your compliance model as is with all the 1, 2, 3 bedrooms and still not have to create separate models. Another one is it corrects PV carryover deficiency and correctly implements net metering, both which are essential for ZNE projects. Some essential current capabilities not yet included in UQAC, and simulate multiple buildings and multiple orientations of a building design, and local central file for previous projects to quickly generate annual updates. And Michael, if you would like to elaborate more on the local central file for annual updates.
What happens over time, let's say for Redwood Energy, that in the 12 years that we've been doing CUAC reports, that we've done these for about 350 large multifamily housing projects throughout the state. And so we and other developers that use this tool have to rerun them at least once a year in order to pick up the new electric and natural gas rates. And so this is an involved process. So the new CUAC is not yet able to do that. So that's a very important capability to be able to do that. Ideally, what would happen is all this would be retained in a database by the CEC, and the CEC themselves could just run the annual updates without the local analysts needing to do that. Some additional desirable future capabilities is gradually the state is starting to require, and eventually will make time of use rates almost universal. And so those are not included in either the current CUAC or the new CUAC. So that's going to be important in order to get projected utility costs correctly. The other thing that's happening statewide is that majority of utility customers now are under community choice energy programs that are also called community choice aggregation. And so the current CUAC tool only includes the electricity rates for the local utility and not for the local CCE. And so that needs to be included. And currently water consumption, if you change water consumption in the tool, it changes it for all projects. And so the tool needs to be changed so it can be set individually for individual projects based on what the expected utility use or water use will be in that project. And also, a lot of times water rates are set in very different ways. Some use a base rate plus consumption, other use a minimum charge. And so that has to be done in a way that reflects the actual cost of water under that particular water utility. And finally, that what's really important about the CUAC tool at all is what's been called the split incentive, where one party pays for the utility, for the efficiency upgrades or PV, and somebody else benefits. And so the CUAC tool allows the developer to recapture the cost and gives them more incentive to make the projects more energy efficient and to use PV, and that allows them to do more projects. And so Sean Armstrong has calculated that what he expects is the number of projects that were built that otherwise would not have been built if the CUAC had not been in operation.
I'll add that was about 5%. So the projects, this doesn't increase the profitability for the developer. It doesn't increase the rents, the total housing cost. It flattens their utilities down to about $10 a month, and their rents are maximized, but the two together are always set at 30% of their income one way or another. So it's just less money going to the utility and more money going into building the development. And so many of our projects literally wouldn't have been built because they didn't have quite enough money in them, quite enough rent coming in to pay off the debt of building the project. And so we were able to shift the expense away from the utility and into debt payment to build subsidized apartment complexes. This all works within like regulations, and it's plan checked, and people have to be certified, and this is not the wild, wild west of market rate housing, I wanted to say, but this is a very successful strategy within regulated housing. I'll pause there.
Thank you, Sean. So now we have time for questions.
Oh, that's awesome. Yay! Woo!
Thank you.
That was fantastic. So in your work comparing the new CUAC and the old CUAC, were you able to see how they predicted different amounts of energy for the same apartment design? Did you have a chance to look at that yet? Because they have slightly different algorithms.
Yes, I haven't gotten that far yet. I still need to play a little more with it, and probably even look at one of Michael's old projects and then just run the same, run it in CEPE, sorry, and then see like the compare the results. But we haven't gotten that far yet.
Well, you guys did a ton of work because I know the thing just came out. So
Yeah.
I was watching, it was great. Like, oh my gosh, look at all this. I haven't seen it myself. This is so important. It's great. Good job.
Thank you.
Alice LaPierre, she asked, Michael Winkler, how do we guard against a contractor who tries to value engineer out some of the higher efficiency equipment during construction? And sounds almost like she's concerned maybe it'd sneak it out. And she goes on to say, this will take a very dedicated project manager to keep an eye on all the details. So Michael, how do we deal with that?
Well, it also takes a dedicated analyst, because what's going to happen is once the information comes back to the analyst about any changes that are made in the project, which they're required to do, then the analyst can quickly redo and update the CUAC and inform the developer who is counting on this being there, that this is going to be a financial impact on the financing of your project if these changes are made. So to get that feedback quickly to the developer, that, this is an incentive, and value engineering would take away that critical incentive for being able to finance that particular project.
What we see is that when people try to value engineer out the high efficiency, whatever, the walls, the windows, the HVAC system, and then we say, well, your solar array is finished being designed, so now your utility allowances are going to go up. Utility bills are going to go up, right? That means you're going to lose rent. And that completely reorients the owner, and they tell the general contractor to back off. And so that happens fairly often, to your point, Alice, and that is our fairly frequent response. It's like, well, you lose rent. And since, once again, this doesn't increase the profitability of the project for the developer, because all that's regulated, but it does actually impact their ability to close or ever get repaid themselves, because they sometimes put in like personal loans into the development. So do they get repaid at all? If the rents aren't high, because they're usually low in the repayment stack. They don't get the money first. They get it much later on after other banks have been paid. So yeah, that's the answer there, Alice. Oh, you like the response. Well, good. Bob says, your comment on sneaking things out seems to only be shifting the costs or revenue loss to others. Yeah, I mean, sometimes we've had people like literally try to sneak in non-Energy Star refrigerators. And so during our inspections of all the receipts, we would notice that. And I count that as sneaking, because it was pretty obviously something weird going on, the way the receipts were coming in. And it's uncommon, thankfully. Usually you get notified and then you explain that it changed the project's finances, and no one really wants that to happen. But nonetheless, it's an argument for like having third-party plan checkers and third-party inspectors always during construction, because you're building people's homes, which is literally the most expensive thing that ever gets built for someone, more expensive than their car. And not inspecting it allows people to do the wrong thing. Carl asks, can anyone clarify what percentage of renters have utilities included in their rent versus having their own electric bill? This changes the dynamic of cheating by using low efficiency equipment. Well, Carl, in California, there was such an epidemic of cheating when there was sub-metering of people, of tenants, of renters. When landlords were allowed to sub-meter and then bill the tenants, they would cheat and they would overcharge. And so in the 70s, a law was passed that requires everyone in California to have their own electric meter. In other states like neighboring Nevada, there's no such law. And the common way that apartment complexes are built is the owner pays all the utility bills there. And like when I've been there, they're just like, no, why would we sub-meter? It takes all this room and money and space and things. And you're right that it changes the dynamic when all of a sudden the owner really clearly is paying utility bills and everything that goes wrong costs them money as opposed to being traditionally shifted over to the tenant. So yeah, let's see here. Any other questions that people want to dig into? Oh, I was wondering, Bob Guimarin, I know I'm butchering your last name. I apologize, Bob. But I was wondering, Maria or Michael, I could pass on his question. He wanted to know about some of the advanced solar modeling options, like solar windows or solar shades. And I was wondering, when you guys are playing with the NREL software, I think that solar shades, like panels on the sides of buildings, that's normal. But have you ever seen solar windows in the software?
No, I have not. I still have to play more with the software. I went using from the beta version to this 2.1 version, and I still have to play more with the 2022 version. So if I find something, I'll definitely let you know.
One of our most popular online presentations from previous conferences was a solar windows manufacturer who presented. If you guys go onto our Redwood Energy YouTube page, you can find that. Everyone thinks that one's fascinating. Onyx, one of the world's leading solar windows companies, Onyx presented. I'm sorry, what were you going to say, Michael?
Oh, well, what happens is the input to the CUAC tool is the PV production per month. And so we're agnostic as far as where that's coming from. The point where this starts becoming important is on the mid-rise and high-rise affordable housing projects that we've started to increasingly work on recently. And on those, there's now a sort of battery PV requirement. So being able to minimize use of batteries beyond what is good for the tenants and put in enough PV to still meet compliance, it is going to be necessary to find more creative ways of where to be producing the solar energy on the building, such as you're saying these other types of things like solar windows. And so there's going to be a lot more incentive for these more creative ways of PV production than there has been in the past as they now start increasingly electrifying these taller buildings.
I thank you for bringing that, because I was going to show it later, but is it possible to share the slide to illustrate your point there, Michael, real quick? Could I?
Yeah, I'm going to stop sharing so you can go ahead and share.
So this slide here is what Michael is saying, where we've got a mid-rise building. It's I think 6 stories, North Fair Oaks, San Mateo. So right now the prescriptive 2022 code is going to cost $580,000, comprised of 119 kilowatt hours of battery and 104 kilowatts DC of solar panels. And that's what the code would tell us to do. And that costs $5,600 per kilowatt DC of the solar panels, even though, and I'm saying the battery cost is associated with the solar cost there. On the right-hand side, there's about 20% more solar put on this building, and it'd have to be put either on a canopy over mechanical systems, because that wouldn't be normally a place that solar goes. And so you can count it as additional solar. The same with putting it on the walls. That's extra. So if you put in, instead of 104 kilowatts, you put in 126 kilowatts, you don't have to put in any battery. And that costs about $3,200 a kilowatt, or total $403,000. This is from actual bids that we got for this actual project and our actual models for it. And you can see how if we add a little bit more solar, which benefits the tenants financially, we can get rid of the battery, which doubles the cost, not doubles, it adds an extra 60-70%. It adds a large amount more money, basically, because everyone's shocked. Our clients have all been shocked by how expensive it is to add the batteries in compared to what they were doing with PV. So this is why Michael and Maria have been doing this analysis of what do we have to do to add more solar, which benefits tenants and lowers the cost of the solar array, and leave out the grid serving batteries, and let the utilities put in their own big batteries. Don't do it on the dime of affordable housing, which is my political thoughts on the topic. Okay, thanks for that. Do you want to respond to that, Michael or Maria?
Oh, only that I think one thing that people confuse is batteries used to provide backup and versus batteries that just sort of benefit the grid. And so what a developer, it sounds like developers are doing now, is putting in enough batteries to provide a certain level of backup, but not providing this extra level of batteries that are prescriptively required that don't really benefit the tenants particularly. And the other thing that comes up with batteries is batteries take up space. So if the batteries are put within the building, that means there may be one less apartment that's available, space for an apartment in the building. And that's something that we don't want to see.
Yeah, we are seeing like small batteries being put on the back of the solar panels, but it's a very expensive strategy to have lots and lots of little batteries. So with that, we should move on to our next presenters. Yay, Michael! Yay, Maria! Thank you!
Thank you.